SungoldPower has a new 11.4 kilowatt, 48 volt split phase hybrid solar inverter that actually works quite well. You're going to have a hard time beating the performance and features packed into this unit, and it's priced very competitively. SungoldPower sent me this unit almost a year ago to test, and it's taken me that long to make sure everything is working smoothly. There are some things you'll want to know before you purchase this unit. Welcome back to Projects with Everyday Dave. Let's make some power. There's a hanging bracket that makes the inverter very easy to install if you have two people.
Whew, that's not late. Thank you.
If you're scrawny and foolish like past Dave and try and do it yourself, it'll be a miracle if you don't get injured.
You give yourself a hernia.
Fortunately, we survived unscathed.
Okay, I got it.
With the unit hung, the wiring is straightforward. The manual has clear instructions for all the likely configurations. In my case, I'm installing and testing the hybrid configuration with self-consumption. I'll power all the downstream loads with solar, and if there's extra solar, it will charge the batteries. If the batteries are full, it will export to the grid. The manual has clear explanations for every mode and how they work. It's really nice. Here's the spec sheet from page 74 in the manual for reference. I want to be able to test the maximum battery charge and discharge rates of 10,000 watts or 210 amps. So I installed 4-gauge cables per the recommendation on page 9. However, it was almost impossible to get them to fit through the turret. You can install 4 smaller cables as an alternative, but I'm not sure that would fit any better. For the grid and load connections, you can install up to 4/0 wire and take advantage of the 200 amp pass-through. I'm using no more than the 11.4 kilowatts that the inverter itself can produce. So my system is using 4-gauge wire and 60 amp breakers for the load side and the grid side. And those 60 amp breakers are in the load centers connected to this unit. The current sensors go to the grid, line 1 and line 2, and then that cable connects to the CT meter port. For the equipment ground, I can use a 6-gauge conductor that goes back to the main grounding rod for my house. And then I connect the case ground for my batteries as well as all the other grounds for the generator, load, and grid to the central bus bar. The PV inputs can handle 10 to 8-gauge conductors. I'm using 10-gauge. They're the spring lever type. You need to make sure to strip sufficient insulation, and once you release the lever, pull on the wires to make sure it's secure. There are 2 inputs for each MPPT, allowing you to parallel strings at the inverter without a separate combiner box, and that is very nice. The startup voltage is 90 volts and the max voltage is 600 volts. That's a respectable range, and I really like the 600 volt max. It allows a lot of flexibility for your string configurations. Keep in mind the MPPT only works up to 540 volts, so you want to keep your open circuit voltage below 600 volts and your string max power voltage below 540 volts for optimal performance. The unit has a max usable current of 30 amps for the first MPPT and then 22 amps for the other 2. That's very respectable. A 30 amp input at 540 volts is 16,200 watts, significantly more than the max 15 kilowatt input for the inverter. So conceivably, you could max out the inverter using only 1 MPPT. In my case, I'm using 10-gauge wire with 3 strings between 3 and 4,000 watts each. All of the panels in the string should be the same panel facing the same direction, but each MPPT can be different. In my case, the first string is facing south. It's composed of 11 bifacial panels capable of putting out 4,345 watts, and it'll run around 380 volts or so. The second string is 10 standard panels facing south, maxing out at 3,750 watts and running around 350 volts. The third string is my wood rack array facing southeast. There are 8 bifacial SungoldPower panels maxing out at 3,200 watts. Since there are only 8 panels in the string, the voltage is a little lower in the 250 volt range. You can see how having 3 MPPTs allows me to have 3 very different arrays working together seamlessly. One very important warning: a string voltage of 500 volts will easily kill you. Make sure all the equipment is off and the strings are disconnected at the panels before doing any wiring. I also recommend using insulated gloves for some added protection. I made the mistake of working on what I thought was an inactive MPPT while the others were energized and destroyed an inverter. There can be a voltage potential to ground even on an inactive MPPT. Just look at this. MPPT3 has nothing plugged into it. and the voltage across MPPT3 is only 19 to 20 volts. But from negative to ground, it's 210 volts. And from positive to ground, it's 186 volts. Double check with your meter to make sure that there is no voltage present on any of the wiring that you're working on before starting any work. For my battery testing, I connected two DIY base and green batteries. Each BMS is 200 amps, giving me 400 amps available, well above the 210 amp charge-discharge limit for the inverter. These two are base and green version 1 and version 2 batteries. I have full build and test videos for both of these batteries, so you can find those on my channel or on my website. They're relatively easy to build and they have performed flawlessly. I currently have these Gen 1 and Gen 2 packs connected in parallel, and they're still able to communicate with each other using the communication ports. And I'll put the communication settings on my website for your reference. This version 1 battery has 306 amp hour cells in it, and this version 2 battery has 314 amp hour cells. I recommend getting the 314 amp hour EVE cells. They have an actual capacity of 325 amp hours, which pushes your total capacity to 16.6 kilowatt hours. Since this is just for testing purposes, I've connected the inverter to the first battery with 4-aught cables, and then to the second battery with 2-aught cables, just in parallel. Now, ideally, I would have short 4-aught cables connecting these in parallel, and I would take the negative from one battery and the positive from the other battery, and that would get them even more balanced than what I currently have. But even in its current configuration, they are staying within 1 or 2% of each other, and when they charge all the way to the top, they both hit 99 to 100%, no problem. I connected the two batteries together using the RS485B port, and then I connected the primary battery using the CAN port to the BMS port in the inverter. I set the BMS CAN protocol to pylon in the battery, and since the SungoldPower Inverter is already set to pylon from the factory, the communication worked perfectly right out of the box. With all the connections made, double check the polarity on your solar inputs at the subpanel and at the inverter before commissioning the unit. Startup is easy. Turn on the PV, turn on the DC batteries and the DC battery breaker, turn on the batteries, then turn on the DC breaker, then turn on the breaker for AC input. Once it powers up, you can turn on the AC output. I can use the Bluetooth connection to do all of the software setup, and it works great. I click the Bluetooth button, boom, scan the barcode, and it pulls right up. Then I can hit the configuration button. I can set up all the Wi-Fi settings, all the configuration settings for the unit, make sure everything is set up the way I want it to be, and then I can commission it. I can use the Bluetooth app to do all of the settings. They have steps 1, 2, 3, 4, 5. Once it's all set up properly, then we can power it up. One nice thing about the software is you don't need an internet connection. I can use this Bluetooth connection to locally control everything. You do need the app to change settings. The screen is a very nice reference to see the current status, but it's not interactive. There's no way to test every possible configuration and limit condition. I find the most problems just running a system for a few months the way I would want to operate it for myself. In this case, I wanted to connect high voltage strings, run high power devices like my heat pump and car charger from solar or battery, and I wanted to feed back the excess power to the grid. At first, I was very impressed. The software was so much easier to navigate than the previous SungoldPower inverter I tested. The setup was quick, and the best improvement over my EG4 inverter was the much quieter operation. Many times I was running 5 to 8 kilowatts through the unit, and it was completely silent, no fans running at all. We're putting 8 kilowatts into the battery and it's completely silent. The fan's not even on. The fans do get louder at full load, but it's still not as bad as my EG4 unit. Here's a comparison between the units at max fan speed. It would have been significant effort to reconfigure my array to confirm the 15 kilowatt max PV input, but I was able to run steadily in the 10 to 11 kilowatt range, and I hit a peak over 12 kilowatts. The inverter can only convert 11.4 kilowatts, so anything beyond that has to go into the batteries anyway. In this case, we're maxing out the battery input at 10 kilowatts and the remainder, 7.37 kilowatts, is being exported to the grid. If you have more than 11.4 kilowatts of solar input, you need to have depleted batteries to take advantage of that extra energy. Unfortunately, about this time, I ran into a problem. You can see a dip in the solar input all the way down to 0, and then it bounces back up to 10 or 11 kilowatts. There were some clouds floating by, but it shouldn't go all the way to 0 when that happens. I thought perhaps it was just inaccuracy in the data logging, so I measured the current in real time with a clamp meter, and it was actually going to 0. I found it worked fine in grid tie only mode with no batteries connected. I tried all kinds of different battery settings, and none of them fixed the problem. Finally, I determined there's some kind of firmware issue that needed corrected. I then spent a number of weeks going back and forth with the software engineers at SungoldPower to fix the problem and get the firmware updated. They did finally fix it, and I've been running it for several months now to make sure that the problem was completely eliminated, and I haven't had any issues since. They said I was the only one to have that issue, and I'm not sure how I feel about that. Regardless, I couldn't publish a video until I was sure everything was actually working and I could be confident that the results I was getting are the same results you would see. These kinds of issues are slow to get resolved because the communication is by email and it takes a day to get a response each time a change is made. And the firmware can only be updated by SungoldPower, so if you have a firmware issue, you have to contact them to get the latest update. SungoldPower has come a long way with this new inverter. Overall, the specs are very good and it performs as advertised. There are significant improvements over the previous generation. The software and instructions are much better and it runs so much quieter. The idle consumption on the previous generation was over 100 watts, and I measured this one at about 52 watts. That's also a significant improvement. Really, the biggest challenge with this unit is the slow tech support you have if you run into any issues. The layout is nice, the construction is robust, and the price is very hard to beat. Plus, SungoldPower is offering a 5% discount for my viewers if you use the link and the code in the description below. You can use that discount on the 11K15 Pro, like this unit, and on the 7.6 kilowatt unit. You can only use the discount once, and it can't be combined with any other offers. If you want to see a full solar system install from start to finish, watch this video right here. If you want to learn about the best solar panels and how to get the most out of your solar panels, watch this series right here. As always, you can find tons of resources and discounts on my website, projectswithdave.com. Thanks for watching, and I'll see you next time.